So today we're going to be talking about a brief overview of shielded metal arc welding. Sometimes we'd also call it arc welding or stick welding, and those are both slang terms. Now with stick welding, we generally will use a constant current power source, and then we use a stick electrode, which is a rod that's coated in a flux, and when we connect it with a electrical circuit, we get an arc to form, which is that bright light. And when that flux burns, it creates a shielding gas and a slag that covers and protects the weld. Okay, and as we weld, the rod gets shorter and shorter as it burns. You could think of it kind of like a sparkler in a sense, like that. So some ideas here. This is a 7018. It's an 1/8 inch electrode. We're running at about 120 amps, and this is what you want to do. Okay, this is what you want to replicate when you're welding. We're going in a straight line. We're trying not to move the electrode very much. We're trying to go pretty slow. You can also see that we are trying to hold a very tight arc. That's the distance from the rod and the plate while we're welding. Okay, most of the time you want to use the same electrode diameter as the rod for your arc length. Okay, so if this is an 1/8 inch rod, we would want to use an 1/8 inch arc length, or resting it just on the plate works fine as well. Now looking at this here, you can see if you weld it properly, the slag should come off with ease. I was welding on the edge, so the slag sticks a little, but it's not much. I don't have to hammer it off. I don't really have to work hard at brushing off anything, and there's not much spatter as well. So this is what you want. If you weld it properly, if you weld slow enough with a tight arc, this is what will happen. Now I'm going to show you what you don't want to have happen. So this I'm holding like a 3/16, maybe even a 1/4 of an inch arc. You can see I lose the focus of the arc. We get a very erratic movement. We're slinging BBs and spatter everywhere. Okay, we lose the shielding gas that's burning from the flux. We get porosity in the weld. It's just a nasty mess. This is what you do not want to have happen. And there's not a huge difference. Sometimes it can be hard to tell, but as you can see, the end result is not very good. I have to hammer it off with my chipping hammer. I still struggle to get it off with a brush. And this is just an example of what you don't want and how you can troubleshoot. So if your weld looks like this, hold a tighter arc. Most of the time that will fix your problem. Here's a 6010 electrode, an 1/8 inch 6010. I'm burning at about 85 amps. Remember, amperage is the amount of electrons flowing through a circuit. Okay, and when you're done, there should be no spatter because I'm holding a tight arc, and that slag should literally come off that easy. It should almost pop off by itself. If you have to hammer it off, you know you're holding too long of an arc. So here I'm holding too long of an arc. Again, it can be a little hard to tell, but notice the amount of spatter that's coming from the weld itself. There is an erratic motion in the arc if you look at the arc. And what happens is we undercut the plate, that slag grabs into that undercut area. It becomes very challenging to actually scrape off and remove the slag coating. I'm going to cover some pros to stick welding. So here's an engine-driven machine. Okay, it's gas-powered engine that drives a generator. Okay, now with stick welding, you can weld almost anywhere, outside, in a factory somewhere, tight places, you name it, you can weld there. Especially if you have an engine-driven welder where you have an unlimited amount of power source, or you just have a long extension cable. Welders that generally typically use like a engine-driven power source are very critical on their arc characteristics. And if you get them tuned correctly, you can see right here, they're doing a root pass and they don't even have to look at the weld itself. Here's a different type of a root pass. This is a 7016 open root. As you can see here, if you have the skill, you can make very high quality welds on pipe and plate that pass X-ray all day long, but you have to have the skill. Another pro to stick welding is that you can use a variety of different electrodes that allow you to weld different metals for, say, like stainless steel or nickel alloys. There's hard facing alloys. All you have to do is change the rod and you're ready to go. And sometimes you can even buy it in like 1 to 5 pound increments to where it's not that expensive to make a quick repair. Here's a 80-10 electrode doing a downhill cap pass on a piece of pipe. This would be similar to like the 60-10 rods that you run, but it has a higher tensile strength. Okay, another pro to it is in hard to reach areas, or also on welding like dirty material where you just can't clean it as well as you would like. This is used a lot in factories and refineries for repairs or in-service welds, where again, it's a hard to reach area, heavy equipment, sometimes things get cracked and they break, and stick welding is generally the method of choice for welding outside. Some cons to stick welding are, number one, it can be difficult to weld thin material. Generally, 1/8 of an inch is max, and even that's pushing it sometimes. It's also not the quickest process. It's fairly slow, so production means a lot of times they use other processes like flux core arc welding or gas metal arc welding for production. And then there's a material waste as well with the electrodes. You can only burn them so far. Sometimes when you're welding on a project in a hard to reach place, it can be difficult to use the whole rod, so you do get a material waste there. And then there's a skill involved. It can be very difficult to learn, but once you learn it, you have it. Thank you.